Hey guys, okay, so we're going to look at activity series again. Now we just went over it in our last video about how to use the activity series of elements. And so you have a chart on page 11 in your packet of the activity series. Remember that these are only used with single replacement reactions. Okay. And the activity series of metals will be used when you have a positive ion. And the activity series of halogens, which is much shorter, will only be used when you have a negative ion. Okay. So remember that when you look at your single replacement reaction, the element that is a single element that is going to try and kick somebody out of a compound will need to be above that element in the activity series. They have to be more active than who they're kicking out, or else it won't happen. So if you had, say, zinc trying to kick out cobalt, then zinc could do it because it's more active. But if zinc was the single element and they were trying to kick out, say, barium, it could not happen because zinc is not more active than barium. Okay. And the same thing here. There's the hierarchy, right? So those that are higher can kick out anybody below them. But if you're below an element, you cannot kick the element out of the compound and take its place. Okay. So really quick, just to practice a couple here. Remember, let's say zinc is going to be our single element. And then we've got sulfuric acid here that we're going to try and do a single replacement reaction on. So whenever we do this, I always say immediately pick up your periodic table of elements and flip over to your, hold on here, periodic table of ions, okay? And look up these elements. We're going to work with zinc. Let me focus this in. So look up zinc, and when you do, you find that zinc is a +2. So we're going to put that charge over top of zinc. Then look up your hydrogen. Hydrogen is a +1. So H is a +1. Then remember SO4 is a polyatomic ion. So look it up here. Sulfate is a -2. So SO4 is a -2 ion. Now that you see the charges, it makes it a little bit easier to determine who zinc wants to kick out. Remember, like replaces like. So here, zinc is going to try and kick hydrogen out. Okay? So now you've looked up the charges, figured out who is going to try and kick out who. Then we pull back that activity series again. And now we've got to determine, is zinc higher than hydrogen? So I look on my chart and I find zinc here. And I find hydrogen right down here. So zinc is over hydrogen, and this reaction can happen. So now I know that this is a yes. So I'm going to say, okay, now if zinc kicks hydrogen out, that means hydrogen is going to come over here onto the other side all by itself. Okay. And then I look at hydrogen and I say, well, you know what? He's pretty familiar. He's part of Brinkelhoff, right? So he's part of Brinkelhoff. So that means that I have got to take this hydrogen and put it in a diatomic form of H2. Okay? So because he's in Brinkelhoff, he's going to be in diatomic form H2. Okay, now I'm going to go and I'm going to make my new compound that has zinc in it. So zinc, we said, was a +2. Okay? And then write the charges for the other part of the compound, SO4. It is a 2-. And now I'm going to go put these together based on their charges. So I've got a +2 and a -2. So that means I can just put them together as ZnSO4. Okay. And those are my products. And then after you've made your products, then you can balance your equation. Okay. Where you would say, hey, I've got 1 zinc and I've got 1 zinc. I've got an H2 and I've got an H2. I've got an SO4 and I have an SO4. So actually this one is balanced, although if you wanted to, you could come in and count these all up again. Zn, H, and SO4. And you could say I have 1 Zn, I have 2 H's, I have 1 SO4 because I see it intact over here, right? And then you could say I have 2 H's and I have 1 zinc and I've got 1 SO4, so I'm balanced. Okay, so somewhere on that paper, write that down. Okay, then we can move down here. And in this case, we now have chlorine. So chlorine, Cl2, I'm going to go look it up. So again, I come into a new problem. My very first thing is to get out my periodic table of ions and look it up. Chlorine is a -1, so that's Cl minus. Na is a +1, that's Na plus. Br is another halogen right over here, Br minus. Okay, and now it makes it easier for me to determine who does this single element want to replace. Well, this single element is a negative, so they're going to want to replace this negative. Okay, so now I have to look on my activity series to see if it can happen. Is chlorine above bromine? And chlorine is above bromine, right? I'm on my negative ion chart. Chlorine is higher than Br, so this will happen. Okay, so that means my element that's going to get kicked out is Br. And then I have to ask myself, okay, is Br part of Brinkelhoff? And it is. Br is part of Brinkelhoff. So it's going to be listed as Br2. If it is not part of Brinkelhoff, right? If it were some other element other than these 7, it could be written as just a single atom. Okay? But like zinc was a single atom, and that was okay because it's not part of Brinkelhoff. But if you're one of these 7 elements, you've got to be in diatomic form. Okay, and then my last part is going to be chlorine bonding with Na. So the positive always goes first, the negative always goes second. And in this case, I have a +1 and a -1. So I put them together, equal and opposite, 1 of each. Okay, and now I can balance this equation. Okay, I've got chlorine, I've got sodium, I've got bromine. And I'm just going to do a quick count. 2 chlorine, 1 chlorine, 1 sodium, 1 sodium, 1 bromine, 2 bromine. So I'm going to say, well, these 2 need to balance. I'm going to put a 2 over here. Okay, and that balances the bromines, but the sodiums are not balanced and the chlorines are not balanced. So I'm going to put a 2 over here. And these are now balanced, and I'm good. Okay, and last little practice, Na and KCl. So again, I'm going to get out my periodic table of ions, and I'm going to say, okay, what are my charges? Na is a +1, K is a +1, and Cl is a -1. So now I can see who sodium wants to kick out. It wants to take out the like charge, which is the positive. So now I got to go look at my activity series. Is Na higher than K? I see K. Here's Na. Na is below K. So no, this cannot happen. Na is below K. So no reaction. This will not take place. Okay? So again, just 3 practice problems here to look at. So I would like for you to take out page 14 now, and let's go over 14 together. Okay, so we're going to go through some practice problems on 14. It wants us to, again, do exactly what we were just doing. If there is, determine if there's going to be a reaction. If there is not a reaction, we write NR or no reaction. if there is a reaction, we have to predict the products and balance. Okay, so I'm going to go get my periodic table of ions, and I'm going to go look up what everybody is. So Al is a +3, H is a +1, and Cl is a -1. Okay, so now I can see that Al wants to replace the positive of H. Okay, so now I can go get my activity series, and I look and I say, okay, is Al above H? And it is. Al is above H. Caitlin, can you go close that door? Okay, so Al is above H, so this is a yes. So that means H is going to be kicked out on its own. Okay, H is kicked out. Now, what do I know about H? Well, I know that H is part of Brinkelhoff. And if you need to, anytime you take a test or whatever, go ahead and check, is that H part of it? And it is. H is part of it. So that means I'm going to put it as H2. Okay. And I'm going to come over here and I'm going to say, okay, so H is out. So aluminum is going to try and bond with chlorine. Al is a +3. Cl is a -1. And now I can put my compound together based on these charges. I have to have the charges to be able to figure it out. So I'm going to crisscross applesauce. I'm going to get AlCl3. Okay. And so that is my single element and my new compound. Now what I can do is I can balance. I can say Al and H and Cl. And then I can check where we are. 1 aluminum, 1 hydrogen, 1 chlorine, 2 hydrogen, 1 aluminum, and 3 chlorine. So I can say, okay, I need a 3 here. So that gets me 3, and that balances, but now I've got 3 and 2. Oh no. So that's not good. So I need these numbers to be a 6. Okay, so to get a 2 to a 6, I'm going to multiply it by a 3. But to get this back up to a 6, what I can do is I can either use a second coefficient times the first coefficient, or I can scratch this out and scratch out my 3's and say, okay, I need a 6 here. So that means I'm going to multiply a 6 times my 1, and I'm going to get a 6 on both of these. If I had used another coefficient, I would have just looked at 2 times 3, which is the same thing as a 6. Okay. So I have a 6, and that changes these. So that balances my hydrogen, but it throws off my chlorine. So I need to double this to a 6. And then I need to come all the way over here to aluminum and use a 2. And so I have a 2 and a 2, a 6 and a 6, a 6 and a 6, and I'm 2, 6, 3, and 2. Okay, so that's balanced. So we move to number 2, and I have fluorine and hydrogen and bromine. So I'm going to go look up their charges. I'm going to use my periodic table of ions again. My fluorine is going to be a -1. My hydrogen is going to be a +1. And my bromine is going to be a -1. Okay? So now when I look at this, I can see that fluorine is a negative, and it's going to want to replace the other negative. So it's going to come in here and try and kick out bromine. But can it do it? So now I got to go to my activity series, and I have to find fluorine and bromine in my negative ion column. And fluorine is above bromine, which means it's more active than bromine, and it can kick bromine out. So this is a yes. Okay, so bromine's going to get kicked out, but I need to check, is bromine part of Brinkelhoff? Yeah, it is. So that means that bromine has to be written as a diatomic. And now fluorine's going to come over here. Hydrogen is going to bond with the fluorine. And so my compound is going to be +1 and -1, or equal and opposite. So I just get HF, one of each. Okay, now that that's done, you can balance. and you have F and H and Br. Okay, and you have 2 fluorine, 1 hydrogen, 1 bromine, 2 bromine, 1 hydrogen, 1 fluorine. Okay, so I see 2 and 1, so I'm going to bring a 2 over here. Those are balanced. These are not, so I'm going to bring a 2 over here. That's balanced, that balanced, and I'm done. Okay, let's look at number 3. Okay, Ki plus Fe, iron. And so here we want to look at, is iron capable of kicking somebody out? Okay, so again, we're going to go through this problem, and we're going to look at charges. So K is a +1, I is a -1, and Fe is actually a transition metal. It can be a +2 or +3. It really doesn't matter which one you pick when it's a single. You can pick the +3 because it's the top one listed. No big deal there. Okay. And now we know that my single element is a positive. So that means I'm going to try and kick a positive out, which would be K. Okay. But can that happen? So here's K. And I need to find Fe, and it is down here. So, whoops, there we go. Fe is below K, so this is a no. Okay, Fe is below, no go. Maybe that'll help remind you. Okay, Fe is below, no go. So this is going to be a no reaction. Okay, so as we start number 4 together, I want you to pause the video as you need to so that you can look up your charges and try and see if this is going to happen. Okay, so if you want, give it a pause right now and then look up your charges, write them up above like we do. Then you can try and decide who is going to replace the other. Okay, look for the like element to replace it. And then you can use your activity series to try and decide if it's going to happen. Okay, so pause now, so if you want to look at that. Okay, so hopefully you've unpaused now and you feel a little bit better. And if you did, then you found that H is a +1 and NO3, Cu could be multiple charges, so I'm not sure which. So I'm going to look at my negative ion, which in this case is a polyatomic NO3. It's a -1. Since I only have one of it, that means my copper is +1. And now I know that hydrogen being positive is going to want to take out copper being positive. So I need to find out if that's possible. So I have to find copper and hydrogen on the chart. Hydrogen is here, and copper is... Where is copper? Copper is down here. So hydrogen is above copper, okay? So this can happen. So this is a yes. Okay, so hydrogen can kick copper out. So copper is going to come over here. And now, is copper part of Brinkelhoff? No, it is not. Okay, so we know that copper is going to be by itself, and we know that we're going to make a new compound. So pause here if you can predict your products, and then you can unpause and see if you're right. Okay, so you're back. So copper is by itself, and it's not part of Brinkelhoff, so it's just going to be a single element. Okay, and then our hydrogen, which is a +1, is going to come over and bond with our NO3, which is a -1. And those are equal and opposite, so you're going to get HNO3. And so these are our 2 new products. Okay, and now we can balance our equation. So when we go to balance, we have hydrogen, we have copper, and we've got NO3. So I've got 2 hydrogen, I've got 1 hydrogen, I've got 1 NO3, I've got 1 NO3, got one copper, I've got one copper. Say, oh my goodness, what am I going to do? Okay, so I'm going to use a 2 here, and I'll make this a 2 and this a 2. And that means I need a 2 over here for NO3. So I'll make this a 2 and this a 2. I'll say, okay, that's balanced, but this is not, so I'm going to need a 2 here to make this copper a 2. And then it's 1, 2, 2, 2. Okay, we got 2 more to go. Number 5, SR. So what I'm going to do is, if you want to do these on your own, pause your video and then come back and I'll go over 5 with you. Okay? Okay, so SR is going to be a +2, CA is a +2, and CO3 is a -2. So as we go to as we go to look at those, SR is going to try and replace CA because it's the positive. And then we've got to look and see if strontium is capable of doing that. So SR is here, and it's just above Ca. It is just slightly reactive enough to kick calcium out. So this is a yes. Okay, so that means calcium is going to come over here and be on its own. And I know that calcium is not part of Brinkelhoff, so it'll just be a regular atom. And then I'm going to have SR, which is +2, with CO3, which is -2. They are equal and opposite, so SR, CO3. And those are my new products. And when I look here, I see one SR, and I see one SR. I see one Ca, and I see one Ca. I see one CO3. I see one CO3. So I'm going to say that this is balanced. Okay. And then I'm going to come down to number 6. Okay. Give 6 a whirl, pause your video, and then come back and see if you got it right. Okay. So copper, I'm not sure if it's a +1 or +2, but I can look at fluorine and see it's a negative, and I have 2 of it. So if I only have 1 copper, it must be a +2. And I know that chlorine is a -1. Okay, and again, if you don't remember these, get out your periodic table of ions and look them up. Okay, then chlorine's my individual element and it's negative, so it's going to want to kick out fluorine. So like replaces like, and now I have to figure out if that can happen. So I'm going to grab my activity series. I'm going to go right here and I'm going to say, hey, chlorine's my single. It's trying to kick fluorine out, but chlorine is below fluorine. So this is a no. Cl is below. No go. Okay, so this is a no reaction. Okay. Hopefully those were pretty easy, but you can always come back through it or reprint the page and try and work through some more problems as you go. I do want you to look at your double displacement page, which is the very next page. Now, these double replacements, or you could call it displacements, either one, they are interchangeable names, okay? These do not require the activity series. So we're going to assume that these take place. And you're going to, good thing I can spell, predict products. Okay, so we're just going to go straight into predicting products. So for this one, I'm going to let you guys do the rest of the sheet, but I am going to do number 1 with you. Okay, so AG, I look it up, and again, I'm going to do all the things I would have done before, except this is a double, so I'm going to make 2 new compounds. I'm still going to need my periodic table of ions. So look up charges. Ag is a +1, NO3 is a -1. Okay, NH4 is another polyatomic. It is one of 2 positive polyatomics, and so it is a +1 charge. Okay, and then Cl is a negative. Now, we don't have just a single replacement, we've got a double. So that means my positive is going to come over to my positive and replace. You could do negative for negative, but just make sure that you stick with that. You can't do both. Otherwise, you come right back to AgNO3 and NH4Cl. So we're going to swap one of the partners, okay? Now, we don't have to use an activity series this time to double check. We're going to assume that these are going to take place. And so we're just going to make our new products on this side, okay? So when we make our new products on this side, we're going to say, okay, my Ag, which is a +1, came over here and it bonded with Cl, okay? So Ag +1 and Cl -1 is going to make AgCl. And then my NH4 came over here. It was a +1, and it's going to bond with NO3. That's a -1. And I've got a +1 and -1, NH4NO3. And now I have 2 new compounds. Okay, 2 new compounds. So, and of course you can balance from there, although if you look, Ag and Ag, there's one of each. NO3 and NO3, there's one of each. NH4 and NH4, there's one of each. And Cl and Cl, there's one of each. So this happens to be a balanced equation, and you are good to go. Okay? So you guys are now going to work on 2 through 6. Okay, the rest of this page, which is page 15. And you're going to do that for homework. And then I want you to go to your chemical reactions study guide, which is just 1.5 pages. And I want you to work on those for your homework for the next class. So we have a double displacement page where you're going to work on 2, 3, 4, 5, and 6. So that's 5 problems. And then you're going to go to your chemical reactions study guide, which is pages, hold on, make this big. This is page 16 and page 17, and this is a page and a half. And so you guys are just going to answer a couple questions, bounce 2 equations, kind of go through the flow chart to figure out which elements you have, identify a couple reactions, give me symbols for the types of states of matter, okay? And then, you're going to talk to me about signs that a chemical reaction took place. You're going to look at the activity series, and you're going to predict some products. Okay, so just 5 problems on double replacement, and then a page and a half on the study guide, and that's going to be your next class. Okay, now I will be back in school Tuesday afternoon, and I will be here after school Tuesday afternoon, and then also E-period Wednesday, Thursday, Friday, and after school Wednesday, Thursday, Friday. So just come see me if you got any problems or if you're struggling with anything, and we will be good to go. Okay? Have a great afternoon. Get that work done, and I'll see you soon.